This is the lecture number 5 for the chapter triangles of the class 9th, and we are starting with the last exercise of this chapter. For this we have to do some theorems or the conclusion you have to learn. Now if the two sides of the triangle are unequal, then the angles opposite to the longer side is greater than the angle opposite to the smaller side. Now means that the longer side has a greater angle opposite to it. That is, if in this triangle AB is greater than AC, AB is greater than AC, then the angle opposite to this is angle C, and angle opposite to this angle B, then angle C will be greater than angle B. Now similarly, if AB is greater than angle, if AB is longer than BC, then AB opposite to this angle have C, and to angle opposite to angle B, side BC is angle A, then angle C will be greater than angle A. Now similarly, if BC is greater than AC, then the angle opposite to angle BC, side BC is angle A, and the angle opposite to AC is angle B, so angle A will be equal to greater than angle B. So we write like this: the longer side has a greater angle opposite to it, and longer side has a greater angle opposite to it. Similarly is the opposite. In any triangle, the side opposite to the greater angle is longer than the side opposite to the smaller angle. That is, the greater angle has a longer side opposite to it. It is just the opposite of this. Now if in this triangle angle B is greater than angle C, if B is greater than angle C, then the side opposite to B is AC, and the side opposite to angle C is AB, then AC will be longer than AB. And similarly, if angle A is greater than angle B, angle A is greater than angle B, so side opposite to angle A is BC and side opposite to angle B is AC, then BC will be longer than AC. That is, the greater angle has a longer side opposite to it. Don't have to prove this theorem. Now we have to prove that the third is the sum of any two sides of a triangle is greater than the third side. In any triangle, you have done this in the lower classes also. AB plus AC is greater than BC, AB plus BC is greater than AC, and AC plus BC is greater than AB. The sum of two sides of a triangle is always greater than the third side. Now in this last conclusion, that is, the exterior angle of a triangle is always greater than the interior opposite angle. Now suppose if we have this triangle ABC and we draw like this, then if this is the exterior angle, angle ACD will be greater than angle A, as well as ACD is greater than angle B, interior opposite angle. We have done the theorem that exterior angle is equal to sum of interior opposite angle. Now because this is the sum of these two, then naturally this angle will be individually greater than these two interior angles. So these are the conclusions you have to do. Now in question number 1 of exercise 7.4, you have to prove that in right angle triangle, the hypotenuse is the longest side. So in this triangle ABC it is given, angle B is 90 degree. Now you have to 90 degree, AC is the hypotenuse. Then you have to prove that AC is longer than AB and AC is longer than BC. Now in triangle ABC, angle B is greater than angle C, because in a right angle triangle 90 degree is the largest angle. In a right angle triangle, no angle can be greater than 90 degree, always acute angles. So angle B will be greater than angle C. So the side opposite to angle B is AC and the side opposite to angle C is AB. So we can say that AC will be longer than AB, that a greater angle has a longer side opposite to it. Similarly, angle B will be greater than angle A. So the side opposite to B is CAC and the side opposite to angle A is BC. So AC will be longer than BC. That is the same reason I have given in first and second. So AC is longer than AB, as well as AC is longer than BC. So we can say that the AC, which is the hypotenuse of this triangle ABC, is the longest side in this triangle. Now in question number 2, it is given that angle PBC is equal to angle this. It is given. Now you have to prove that AB is longer than AC. You have to prove. Now how can you prove that AB is longer than AC? If we prove that this angle is greater than this angle. So you have to prove this. Now PBC is smaller than QCB. It is given. So in place of PBC you can write 180 minus angle B, and in place of QCB you can write angle 180 minus angle C, linear pairs. So 180 will be cancelled out with 180 degree, and this angle minus angle B is less than minus angle B. To take this angle minus B to the left hand side, it will become positive. Take this angle to the right hand side, it will become positive. You cannot cancel out this minus sign in the inequality sign. So what you have got, that angle B is greater than angle C. So it means that angle side opposite to angle C is AB, this, and side opposite to angle B is AC. So AB is shorter than AC, or AC is longer than AB. This you have to prove. This you have to prove. That is AC. You have to prove that this is longer. That is angle 180 minus angle PBC. It is given that QCB is smaller. So 180 minus angle B, 180 minus angle C cancel out. So AB is shorter than AC. You have to prove it. So in this question number 1. Now in question number 3, it is given that in the figure, that is angle B is less than angle A and angle D is greater than angle C, and you have to prove that AD is longer than BC. Now in triangle AOB, angle B is smaller than angle A. It is given. It is given. So side opposite to angle B is OA and the side opposite to angle A is OB. So we can write that greater angle has a longer side opposite to it. Similarly, in this triangle, it is given that angle C is smaller than angle D. It is given. So side opposite to angle C is OD and side opposite to angle D is OC. So it means OD will be less than OC. Side opposite to angle D OC, side opposite to angle C is OD. See in the figure. Now add step number 2nd and 4th. So it becomes OA plus OD, and is a less than sign here, OB plus OC here. So OA plus OD, AD, OB plus OC, BC, and the less than sign is there. The AD is less than BC, which you have to prove. Now in question number 6, you have to prove that the perpendicular distance is the shortest side length from any point to the line segment. So P is the perpendicular distance, and at any point on this line LBN, if we join PN, then it has become a right angle triangle, and we know that the hypotenuse is the longer side in a right angle triangle. So PN will be greater than PM. Now if we take any point here, any other, and if we call it M, so then PM will also, rather you can take Q, then PQ will be longer than PM. Then means in all the cases, PM will be shorter than any other line segment joining any other line point on the line L. So we can say that the perpendicular distance is the shortest length from any point to the line segment. Now in question number 4, it is given that there is a quadrilateral ABCD in which the AB is the shortest side. This is the shortest side, and it is given that DC is the longest side. And you have to prove that angle A is greater than angle C and angle B is greater than angle D. So we are taking the triangle ABC first, then we take ADC. Now in ABC, now because AB is the shortest side, so we can say that BC will be longer than AB. It is given that AB is the shortest. See in the figure. So because BC is longer than AB, so angle 1 will be greater than angle 2. Longer side has a greater angle opposite to it. Now in triangle ADC, because CD is the longest side and AD similar, then we can say that DC will be longer than AD, because CD is the longest side in the quadrilateral ABCD. Now DC is greater than longer than AD, so angle opposite to DC is angle 3 and angle opposite to AD is angle 4. So we can say that angle 3 is greater than angle 4. Now add left hand side and left hand side and right hand side of first and second. Adding the step number first and second. So angle 1 plus angle 3 is greater than angle 2 plus angle 4. Angle 1 plus angle 3 is greater than angle 2 plus angle 4. So angle 1 plus 3 is angle A and angle 2 plus angle 4 is angle C, like this. Now similarly, we can join BD and we can prove that that is angle B will be greater than angle D. Try to prove yourself. First of all, take this triangle, then when you join this, you take the triangle BAD and BCD, and you can easily prove that this angle B is greater than angle D. So this is the question number 4. Now in question number 5 of this question exercise, last exercise, it is given that PR is, see the figure where PR is longer than PQ. PR is longer than PQ and PS is the angle bisector. So it means this angle will be equal to this. I will write it equal to X. Now you have to prove that angle PSR is greater than angle PSQ. This angle is greater than this. You have to prove. Now because it is given that QPS is equal to angle PRS, so I will add these two angles is equal to X. Because these are angle equal, so I will add it equal to X. Now it is given that PR is greater than PQ, PR is greater than PQ. It is given, so angle opposite to PR is angle Q and angle opposite to PQ is angle R. So angle R will be greater than angle R. Longer side has a greater angle opposite to it. Now see the steps carefully. Now in place of angle Q, I can write 180 minus angle X plus angle PSQ. In place of angle Q, I can write 180 minus angle X plus angle PSQ. See the step. And in place of R in this triangle, I can write 180 minus angle X plus PSR. Some angle property of the triangle. I have to find this angle Q, then I can subtract these two angles and subtract it from 180. And if you have to find this angle, I can subtract the sum of these two angles from 180. I will add this angle R. So see this. Now simple. Now after this, open this bracket, minus X minus PSQ minus X minus PSQ, and simple using the rules of mathematics. 180 will be cancelled out with 180 degree. Take X minus X to the left hand side, so X will be cancelled out this X, and takes PSR I have taken to the left hand side, PSQ I have taken to the right hand side. I am trying to make all the terms positive by changing the side of this inequality. So X will be cancelled out with this X, and PSR is greater than PSQ. This you have to prove. So this is the question number 5, is the last question of this chapter also. So try to do these questions very carefully, and by writing it or solving it at least 2 to 3 times, then you have a good command over these types of questions. Thank you.